Good morning, one and all. Today, I am going to teach the hashing techniques. Before that, I will introduce myself. I am S.A.E.C, working as an assistant professor, belongs to Artificial Intelligence and Data Science from S.A.E. Engineering College. So, today, GATE lecture topic I am going to discuss is hashing techniques. So, I am going to cover the syllabus. What is the need of hashing? Why actually hashing required in data structure? Second is basic concepts of hashing. Third one is what are all the challenges we are going to face in hashing and how we are going to overcome that hashing using collision resolution techniques, and we can cover one more hashing technique called rehashing and then applications, and we will see some previous year GATE questions with the solutions. Okay, actually hashing is required. Hashing, if you see, hashing is inevitable in data structures and database management systems. So what is the need of hashing technique? Before that, we have to go through what is linear search and binary search. Okay, suppose we have a large amount of data. We need to handle those data by performing some standard operations called insertion, deletion and searching. So first we will see what exactly linear search will do. If you take an array, it consists of some elements. I want to perform searching operation. So main thing is linear search. If you are performing linear search, the array might be in sorted order or unsorted order. It doesn't matter how the elements are arranged in the array. But the thing is, here it will perform any operation linearly. As the name suggests, it will perform all the operations linearly. So I want to search some element which resides at nth location. So linear search will starts from 0 and it will start searching linearly until the data elements find out. So here it performs linearly. So if I am having n elements, it will take order of n time. So if suppose n is 5, so 5 elements are presented in the array. I want to perform 5th element, it has to perform 5 searches. So that is what here the complexity is order of n. Okay, what binary search will do? Binary search will take the searching operation for order of log n times. For example, binary search, here the primary thing is the array should be in sorted order. Whereas in linear search, array might not be in the sorted order. So if you are performing binary search, the array should be in sorted order. If it is not in sorted order, you have to perform many sorting techniques like bubble sort, quick sort, depends upon the situation. So you have to perform some sorting techniques to make the array in the sorted order. Then only you can perform binary search. So here my elements like 1, 2, 3, 4, 5. So while performing binary search, first it has to find the middle element, then it will start searching the elements. Whether if suppose I am searching the element larger than the middle element, it will perform searching at the right side of the middle element. If it is lesser than the middle element, it will perform left hand side of the middle element. So here binary search reducing the searching time n by 2. So this one I can say in the complexity term order of log n. Is there any data structure where insertion, deletion and searching for the items in the data structure are more efficient than these two techniques? Yes. There is a data structure called hash tables. Which perform all the operations in the constant time, which is nothing but order of 1. Okay, now we will see basic concepts of hashing. Before going to the topic, we will see an analogy. So, with the analogy, I will start to explain the basic concepts of hashing. Analogy here is, if you are reading the book, for that you are going to read the particular topic from the book. First you will search from the index page where that particular topic resides in the which page. So from that page number you will retrieve the particular topic and you will start reading from that. What suppose if you don't have an index page? You have to read starting from the page number 1 and then you will start reading until that particular topic is find out. So here how index page is more sufficient to retrieve the data from the book, in the same kind hashing will act as an index. One more example is, if you go for library. Library consists of more number of books. So instead of searching the books shelf by shelf, rack by rack, you will go through the index where librarian pasted before the rack. You will get the exact shelf number for that particular book. So in these two analogies, page number or the rack number acts as an index value where you can retrieve the actual data. So same concept applies here in the hashing technique. Here page number or rack number acts as an index. The same thing, hash value acts as an index, will refer the particular data in the memory. So concept of hashing techniques is, it stores the keys into the hash table where the value computed by the hash function which refers the location of the data structure. See, here hash function, which is nothing but some mathematical formula which helps you to compute the hash value with the help of the input you are given to the mathematical function. That index value should be unique, which refers the exact location of the data structure. So hash table, which is nothing but data structure that stores the actual data. The third point is, it stores the values in an associative manner, that is, it associates a key to each value. For example, here table looks like an array. Anyway, we will see how exactly the hashing technique works in the data structure. We will see with the help of a diagram and with the help of the example. So here I am having the hash table which exactly looks like a array, whether it is vertical or horizontal. I want to get the index value to store the data. So how I will compute the index value? With the help of mapping function, I can say hash function. So how this hash function will works to compute the index value? This hash function will take the key values, otherwise our actual data has an input. Based on this key value, it will compute the index. Index is nothing but it refers the location of the hash table where exactly our data going to reside in the table. How this hash function will helps you to compute the index value? We will see little later in this session. So here each key value associates with index value of the array. One more important thing is, for each key values, hash function should compute the unique index values. That is the property of hash function. So for 3, it has to give the, or it has to yield the some unique index value. If you take 2, it has to give the another unique value to store the 2 in the hash table. So the basic property of hash function is it has to yield the unique hash values. So this process or this technique is nothing but the mapping the keys to the values in the data structure is known as hashing. Okay. How this hash table looks like? We have already seen that it looks like an array of fixed size, which means before implementing the hashing, you have to fix the array size or the hash table size. If my hash table size is 10, means I can accommodate 10 elements in the hash table. Now, how I will refer the index? Obviously, my table size is 10, means my index value ranges from 0 to 9. So, 0, 1, 2, 3 up to 9. Each key, my data, whatever I am going to store in the hash table, which means each key is mapped into some number which ranges from 0 to table size minus 1. Here I am taking the example of 10. So which means key values, whatever the data, with the help of hashing function, that hashing function should yield the hash value in the range from 0 to 9. We will see what is hash function little later in 1 or 2 slides. Okay, don't worry about whatever we have seen the concept. I am going to explain this with the help of a diagram and with the help of an example. Now you will get a clear picture. Okay, we will see how does hashing in data structure works. See, this has 3 steps. One is input, another one is hash function, another one is output value. Here input is nothing but my actual data. So input is nothing but my data, which I am going to store in the hash table. Hash function, some mathematical formula which helps you to compute the index value, or I can say which helps you to compute the hash value, unique hash value. This hash value refers the location of the hash table. In this table only, we are going to store the data with the help of the hash value. For example, my input values, my data are 7, 16, 33, this is nothing but 41. I am taking some mathematical formula as an hash function to compute the hash value. So my hash function is, x is nothing but my key, mod 7. So here, first input is 7. I want to store 7 in the hash table, but I don't know where I want to store this. So here, with the help of hash function only, I am going to compute the hash value to store the input or key 7 in the hash table. So here my hash function is x mod 7. Mod is nothing but you are going to take the remainder of it. So 7 mod 7, which is nothing but 0, because 7 divides completely by 7. So 0. So here I got a unique hash value for this input 7. So 7 going to store in 0. Whenever you give the 7, it has to always yield the value 0. If I want to search or retrieve the data 7, because 7 resides at 0. So 7 is the input of this map function. It should always yield the exact hash value. Okay, but for each key, it should yield the unique hash value. That is the difference. That is the property of hash function. If you take 16 mod 7, obviously 2, remainder is 2. So in the index 2, we are going to store the 16. As like 33 will store at the 5 and 41 will store at the position 6. So here my table size is 7. So here I can accommodate 7 elements in this table because my hash table is a fixed size of array. Okay, what are the challenges then? What are the challenges in hashing? Here we have seen 3 things. One is key. So here we have to see 3 things. One is input, which is nothing but keys, hash function, and output, which should yield the unique hash value. Okay, which means this hash function plays a vital role to yield the unique hash value, because this hash function going to tell where this data going to reside in the hash table. So how to choose this hash function? In the next slide, we will see the properties of hash function and what are the various types. So first challenge is how you going to choose the hash function so that hash function will yield the unique hash value. Second thing is collision. Don't worry about this term collision. I will tell you little later after 2 or 3 slides what is collision and how collision occurs with the example. Collision is nothing but when 2 or more key values going to have the same hash value. For example, 33 and 43. These 2 values exactly represent the same hash value, say 3. So in the hash table, at the position 3, 33 already stored, 43 also colliding with the 43 which resides at 3. So here 2 keys are referring the same hash value. So if I want to store 43, there is a chance I can able to lose the data 33, which should never allow in the data structure, because data is very important. So whenever I want to search 33, it should be there. Whenever 43 should be, I can able to retrieve those data. So how this collision we going to overcome in hashing? This is the major challenge in hashing technique. So 2 or more input keys are going to have the same hash value. That is nothing but collision. So first one is how we going to choose the good hash function, and second thing is how we going to overcome the collision. Next is, first we will see the challenge of hashing techniques. The first thing is hash function. Okay, before going to see various hash functions, we will see the properties of hash function. So that hash function, it's a mathematical formula, right? That one will yield you the unique hash value. The first point is it must return number 0 to table size. I mean, for example, my table size is my table size is 10. Whatever hash function we are going to choose, it should always yield the hash values in this range 0 to 9. That is the first point. Second point is, of course, our main advantage of hashing technique is it always perform all the operations at the order of one time, in a constant time. This is basic advantage of hashing technique. So whatever hash function we are going to choose, it always efficiently compute order of 1. Third point is, it should not waste space unnecessarily, of course, because memory is very cost. So if you want to buy RAM or whatever, it's very cost. So you should not waste space unnecessarily. So which means my table size is 10, my hash function, whatever we are going to select, it should use all the slots efficiently. And one more important thing is, the keys what we are going to actually store in the data structure hash table, it should evenly distribute. So this third point is very important. Keys should be evenly distributed by the hash function, and it should not waste memory space. And second important thing is load factor. This is nothing but how we are going to effectively distribute the elements evenly or uniformly in the hash table. So the formula here is lambda is equals to number of keys divided by table size. So here this is nothing but it tells you the capacity of the hash table. We will see one previous year's gate question based on this load factor. The last but not least, the important thing is, whatever hash function we are choosing, it should always minimizes the collision. So these are all the basic properties while we are choosing for the hash function. So I have mentioned here only 4. There are so many hash functions. First one is basic method called division method. Key mod hash table size. Second one is multiplication method. Here key is nothing but our actual data. So with the help of the data only, we are going to compute the hash value. So key into constant mod hash table size. Third one is mid square method. It's a two-step computing method. Here first it will take the key value and it will square off that key value. Second step is it will choose the hash value from that output value which occupies at the middle digits. For example, if you are taking key 12, so first step is I have to make a square of it. 12 square, which is nothing but 144. So here second step is I am going to take the middle element of this. So here my hash value is 4. So 4 will be the hash value for this particular key 12. If you take 11, 121, so 2 is the hash value for this element 11. So if table size is 10, you can choose one middle element. If table size is 100, 0 to 99, you can choose 2 middle digits. Next is universal hashing. This is the important hashing function were designed to minimize the collision. Like these are all some of the examples. H of x, x is nothing but my key, or you can say k also, whatever. A into x plus b mod p, which is nothing but a and b are the random coefficients, x is the key value, p is the prime number. This works well for the integers, and this particular function which helps you to reduce the collision. Some more functions like h of x is equals to matrix into m. Matrix into x. So this particular function which helps you to store the strings in the data structure. Now we will see second major challenge, collision occurrences. So here what is collision? I have already mentioned that when 2 or more input keys are trying to reside at the same location in the hash table. So here with the example I will let you know what is collision occurrences. For example, we are having the keys 16, 21, 26, 20. Table size is 4, which means I can able to accommodate 4 keys. So my hash function I am using here is division method, because key mod hash table. So 16 mod 4, obviously remainder is 0. So for 16 it will for 16 it will take the position 0. Meanwhile for 21 1, 26 2, but for 20 it referring 0, but 0 already occupied with the value 16. This is where I can say collision. So here 16 and 20 refers the same value 0. So how, but I want to store 20 also, because my data is 16, 21, 26, 20. I can accommodate 16, 21, 26 without any hindrances. But the thing is I want to, while storing 20, I am having the collision problem. So how I am going to overcome this collision? With the help of these techniques. There are 2 main techniques. One is open hashing, another one is closed hashing. We will see one by one these techniques. First one is open hashing, which is nothing but separate chaining. Here each hash table slot contains a linked list of all the values that have the same hash value, which is nothing but if suppose with this example I will explain how separate chaining is working. Here my table size is 9. So hash function is k mod 9, division method. So these are all the keys 19, 15, 20, 33, 12, 17 and 10. If you take, and 5, 28 also. If you take element 5 mod 9, it will give you the position 5. So at the location 5 I can store my data 5. What suppose 15? If you take 15 also, if you take 15 mod 9, it will give you 6. So at the location 6 I can able to store my value 15 without any collision. What suppose 33 mod 9? 33 mod 9 also yields the same value 6 where collision occurs. How I will resolve this? With the help of separate chaining. So here I am going to use the linked list concept. So here at the location 6 I will store 5. As all you know, linked list will have two fields. One is data field, another one is address of the next field. So here I will give the address of the data which this particular data 33 resides. So here it will have the address of this location. So this is how, with the help of linked list, we are going to resolve the collision. So this is the final picture after inserting all the elements in the hash table. So if you take 1, here we are trying to store 3 elements, 28, 19 and 10. If you take 3, it is having only 1 element, 12. If you take 6, it is having 2 elements, 15 and 33. So in this particular slot, I am having the address of the 15th data where it resides, and here in 15 I am having the address of the 33 where it actually resides. So next is linear probing, or I can say one of the important technique comes under closed hashing. So as the name suggests, it will help you to search the next free slot to store the data when collision occurs. So this is the basic algorithm. Then I have to search the next free slot to store the data. So by adding 1 to that hash of the key, and we have to take mod with table size t. So the sequence goes on +1, +2, +3. So with the example we will see how linear probing is working. So this is the key elements we are going to store in the hash table. So hash function we are going to use division method, which is nothing but h of k is equals to k mod table size. So here table size is 10. So first we will see 3 where it going to store the data. So 3 mod 10 is 3. So 2 also no problem, 2. It's a free space, it will occupy. 46 mod 10 gives you the 6 index, index value 6, no problem. But here I am going to try to store the data 6. So while I performing k mod 10 yields the same value which already occupied with the data 46. So here I want to reduce this collision with the help of linear probing. So linear probing formula, it will add the +1 with the key. So if you check the table, 0, 1, 2, 3, 4, 5, 6 already occupies with the data 46, 3 will be 3, 2 at 2. Here 7 is free. So k is 6, 6 plus 1, 7 mod 10. Yes, of course, it will check whether that 7th slot is free or not. Yes, of course, 7 is free. Now I can able to store my data 6 here. So it will linearly it will search. For 11 no problem, for 14 no problem, but while inserting 21, because 1 already occupied with 11. So while inserting 21, it has to search free slots. So with the help of k plus 1 mod 10, then k plus 2 mod 10. This sequence will goes on until table size exceeds. So it will find the location, next free location, here, next free location at the index value 5. So what this props means? Props is nothing but how much time it will take to find the free slot to occupy the data. Here it is taking for 6 2 times to find out the free slot, but for 21 it is taking 5 times. So props is nothing but how much time it will take to find the free slot to occupy the data in the data structure. Next is quadratic probing. The only difference is the interval space between succeeding probes. So here they are taking the interval spaces by calculating each subsequent value of any arbitrary polynomial in the initial hashed index. So the formula is index value already occupied, the next slot index will be calculated by, instead of 1, 2, 3, it will make a square of it. So 1 square, 2 square, and the sequence will goes on until it exceeds the actual table size. So here I have taken the same example with the same keys, same table size. So here obviously till 46 no problem, it will insert the data, but at the 6 it will have the collision. So with the help of quadratic probing and with the help it's searching within 2 times for the next free slot. But here 21 it is calculating or it is finding the next free slot within 3 times, but whereas in linear probing it takes 5 times to search the next free slot. But in quadratic probing, so here because we are taking the index value or taking the next values and we are making the square of it. So instead of searching linearly, it will have some interval spaces to find the free slot. So here for 21 it is taking 3 times to search the next free slot. So this is the resultant hash table after applying the quadratic probing. Next is double hashing. This is also comes under closed hashing. Here, as the name suggests, double hashing, which means it is using 2 functions. So one is primary function, another one is secondary function. Primary function, it helps you to compute the unique index value. When collision occurs, it will get the help from the secondary hash function. So here the formula is first hash key plus I into second hash key mod table size. So we will use this formula only when collision occurs. So here the example. So 3 without any problem it will occupy the slot at 9, 2 at 7, 46 at 5. So within one time itself we are searching the free space to occupy those, to accommodate those datas. But while I am trying to compute the index for the data 6, obviously it yields the same value where 46 going to store the data. So now we are going to get the help from the second hash function. So second hash function gives you the value 9 with the help of that formula h1 of k plus I into h2 of k mod table size, where I ranges from 0, 1 till n minus 1. So until it finds the next free slot, we are going to use this formula. So in this second time itself, we are getting the free slot. While storing the 36, obviously collision occurs, so we are getting the help from the secondary function to secondary function. By using this formula, we are finding the index value 3, but here it is taking 3 times to search the next free slot. So this is the resultant hash table for this particular example. Next is rehashing technique. It will dynamically expand the table size. So here load factor plays an important role to decide when we going to increase the table size. So when rehashing is required, whenever you are having these cases, when the table sizes are full, when the load reaches at a certain level, when an insertion fails. So the first 2 points specifically means the same thing. When it reaches the load factor 0.75. So when my table 75% of the table occupied with the data, now this is the time to expand the data or double the size of the data to accommodate some more data. Next case is insertion fails. You are using some quadratic probing. In linear probing we won't find this case, but if you take quadratic probing, so because of using the squares, it might miss some free slots that will never refer the key values. So it might miss some index value. So at that time, rehashing, definitely we have to go for rehashing. So in this case, rehashing required. Rehashing is nothing but it will double the size of the previous table size, but with the same hash function. So if suppose my table size is 7. So my load factor reaches 0.75 or 75% of the data table is filled. So here I have to double the size, which is nothing but 14, and this size, whatever I am getting after the doubling the size of the table size, the value should be prime number. So it will take, next prime number is 17. Now my new table size is 17. So the hash function should be k mod 17. So now you will try to insert all the data in the new expanded table. So applications of hashing. In this, it will give you the fast search. Searching is very efficient. It should always provide the search operation at the constant time 0, 1. It should be efficient too, and it should be space efficient. It will provide the space efficient, because comparatively if you take another data structures, hash table will require only few size occupied from the memory. So based on this, databases, it will inevitable topic in database management system. It acts as an index to retrieve the large database, and cryptography, caching, spell checking, network routing. Now the time to solve some more previous year gate questions. This question will be taken from 2014 set 1. So here we have a question like collision resolution technique, which means they have mentioned that what technique you are going to use, which is nothing but separate chaining, and the table size is 9. Keys they have given, what are all the keys you are going to store in the data structure. Here the question is, after inserting all the elements in the hash table, we have to find it out what is the maximum, minimum and average chain length in the hash table respectively. Just pause a video and solve by yourself and check whether you have picked the correct answer. Okay, here the solution is, we have inserted the elements with the help of chaining method. So this is our hash table after inserting all the elements in the table. So now we have to find it out maximum, minimum and average chain lengths in the hash table. So maximum chain length here is, index 1 holds 3 elements while 6 holds 2 elements. So the maximum is 3 elements, minimum is 0, because the index or the position 0, 4 and 9 didn't have any data, didn't hold any data. So minimum minimum is 0. Average chain length is, you have to check what are all the index positions holds the how many data elements. So at the 0, 0. So at the index position you will have 0 elements. At the index 1 you will have 3 elements. At 2, 1 element. At 3, 1 element. At index 4, 0. At index 5, 1 element. 6, 2, 7, 0, 8, 1, 9, 0. So my hash table size is 9. If you simplify this, you will get the answer 1. So the option is A is the right answer. Next is hash table T with 25 slots and that stores 2000 elements. So what is the load factor? As we have already seen, load factor formula is number of elements, here 2000 divided by the hash table. So if you simplify this, you will get an option 80. So third question is, a hash table contains 10 buckets and use linear problem to resolve the collision. So they have given some integers, but they are asking in what location 142 be inserted. So pause a video and try yourself and check with the answer. So the answer is 6. So here my table size is 10. My hash value is, hash function is key mod 10. So while we inserting 43, so while we inserting 43, obviously 43 mod 10, it will have the index value 3. So 43, 165 at 5, 62 at 2, 123 at 3. But the thing is, 43 is already occupied. So we are going to use linear probing, which means it will search linearly next free slot. So here next free slot is 4. Here we are going to store 123 at the index value 4. Next 142. So 142, if you take mod, it will give you the index value 2, but already 62 is occupied. So it will search linearly, 3 also occupied, 4 also occupied, 5 also occupied, and now 6, it is free. So here it will store 142, so the option is 6. So the last question is taken from set 1 2010. So here they have given the hash table itself with the insertion values. Now which one of the following choices gives a possible order in which the key values have been inserted in the table? You have to check in which order it performed to insert the data in the hash table. So pause the video and try by yourself, check with the answer. So option is B. First we will try with A. Why not A? 46. Yeah, 6. Because my hash function is k mod 10. 42. No problem. Okay. 34. Yes. 52. 52. While inserting 52, it will yield the index value 2, but already occupied with 42. But here, next free slot is 3. It has to, with this order, the table will look like this. But this is not an order. 23 should occupy at the index value 3. So, option A is wrong. If you take option B, 46, yes, it's correct. 34 also correct. 42, it yields the index value 2, so 2 is correct. 23, yes, correct. 52, yes, 52 is second index value already occupied. It will search next index value, that one also already occupied. It will search next index value occupied. Now it finds the free space. Now this is the place where 52 is resides. Then 33, obviously 3 is occupied with the 23. Again will search linearly until it find out the free space. So hence this option is correct. Thank you, and will be continued in next session.